Hello viewers, myself Dr. Radhika, Professor in Computer Science and Engineering. In this session, I am going to explain certain operations of singly linked list. So first of all, in order to perform certain operations of singly linked list, so first of all we have to create a singly linked list. So now we will see how we can create a linked list, singly linked list. Okay, so whenever we are declaring a whenever if you want to create a singly linked list, so first of all you have to create a node. So how you can create a node? So struct yes node, because I am telling it as S node because it is a singly linked list. So then you can give the data part int data, and next you have to give the pointer, that is struct node asterisk next. So this is how you can declare a node. So this is node. This is the node definition. So if you want to first of all create a linked list, so what you have to do is first of all you have to define a node. So how you can define a node is using a structure, because here we have two parts in a linked list node. So that is, we have the data part and the link part. So here we have two parts. So that's why here we require two structure members. So one is the data part and another one is in the link part. We are giving it as next. So anything you can give. So we call it as link part. So here we are giving the pointer to the next node. So that's why the next node is also a node of type what? The same node, that is S node. So that's why I am declaring a pointer to the self, that is struct node asterisk next, because this one is a node and the next is also an S node. So that's why you have to give a pointer to the again the same node. So that's why we are giving the structure variable of the same node. So this is called as self-referential structure. It is called as self-referential structure because here again you are declaring a variable. Suppose if you declare a structure variable of another structure, then we call them as nested structures. But here what you are doing, you are giving a structure variable, but the structure variable is pointing to the same structure. So that's why it is called as self-referential structure. It is called as self-referential structure. So this is how you can give the node definition. So here whenever if you declare a structure variable, what is the data type of this variable what is the data type of this structure variable? The structure variable data type is, it is struct node S node. The data type of, because here S node, struct S node is a user defined data type. So that is being created for singly linked list. So here what whenever if you ask what is the data type of your node means, so for example if you ask what is the data type of next, it is nothing but struct node. So here it is a user defined data type. Suppose if you take int, it is a predefined data type, but here struct node is a user defined data type. So the data type of int is next is struct node. Okay, so like this we can define the structure node. After defining the structure node, what you have to do is so what we will do is just we will give an alias name to this structure. So because always in our programming we need to refer as struct node. So that's why what you can do is you can give another name. So that can be given in C language using the keyword typedef. What is the main function of typedef is, it will give alias names. That is, you can give some another name to your existing data type. So here what is our data type? It is struct S node. Here what is the data type of our structure? What is the data type of our structure that is struct node. So here you can give, I am giving it as a pointer. I will give it as nptr, that is node ptr. I am giving it as node ptr. So so here what is the data type of nptr? It is this one, like this. So whenever if you want to use the total, instead of using that, you can use it as nptr. So like that you can use it. That is for shortcut purpose. That's all. So now whenever if you want to create a node in the structure. So first of all, I told that whenever if you want to create a node, the node should begin with header. So now that means whenever if you want to create a node, so you need to create a node and you should assign the data in the data part and the link in the link part. So first of all, in order to create the first node, so whenever you want to create a linked list, so first of all we will create a header. We will create a header which is the first node of your list. We will create a header which is the first node of your list. So whenever you are creating this header, so suppose when creating the header node, what will be the link part of your header? Just it will be null. So null we will represent it as like this also. Just simple representation, we will represent it as null. So this means, so here what you are placing? You are placing null in the header node next part. It indicates that there is no list. That means it is, suppose if the head next is null, it indicates that there is no list, that is empty list. So now we will see how we can create the, first of all, how we can create the header node. So for that one we will write the function. So what is the return type? So after creating the node, it will return the pointer to this header node. So that's why the return type of the function is, it is nptr. Instead of nptr, if you want, you can also give it as struct snode asterisk. So because it returns a pointer to your header node, so you can give either nptr or you can also give it as struct snode asterisk. So this is the return type. Why we are giving it as return type? Because here it will create a node, that is your header, and it will return the address of this particular node. So that's why we will get the pointer as struct node pointer. Okay. Next what we have to give? We have to give the function name. So what is the function name here? It is create header. Create header. And because we don't have any list, so we have not yet created any list. So that's why this, in the parameter list we are having nothing. So you can give it as empty braces or also you can give it as void. So here what is the function name? Our function name is create header. Our function name is create header. So now we are creating our header node. So while creating the header node, so first of all we have to declare a variable of type what? Structure node, because this is also a node. So what you have to do? You have to create a variable of your structure node. So how you can declare it? So here also you can give either nptr or also you can give struct snode asterisk. Instead of giving every time struct snode asterisk, so for that one, just for simplicity purpose, we have given it an alias name, that is nptr. So here nptr is what? It is of now what is the data type? If you ask what is the data type of H means what? It is a user defined data type and it is struct node asterisk. So the data type of H is struct node. Struct snode is the data type of H. So like this you have to know the answer. Okay. So now first of all what we have done here? So first of all we have created a header node. So we have created a header node of type struct node. Okay, so we have created a node, and then what we have to do is, so now we have to allocate first memory to H. So whenever we want to allocate memory to H, so what is the syntax of malloc function? The malloc function syntax is, so malloc function is a function that is used for allocating memory for your variables. Okay, so this function is available in alloc.h header file. So the syntax of this function is typecast type. So whatever type you want to do, that is, this is typecasting. Next you have to give the function name, and then you have to give the block size. What is the memory block size you want? So this is, and this will be assigned to some variable. So that means what? It will allocate this much block size of memory, and it will convert it to that particular type, and it will assign that address to your variable. So this is the syntax of you can allocate memory to any particular variables at the time of at runtime. Okay, so now here we want to allocate memory to what? Now I want to allocate the memory to H. So for that one, now H is the variable. So for H I should get the address of this particular node. So now H is the address. H is the address, and now first of all I have to do the typecasting. So for typecasting, what I have to do? So I have to convert whatever pointer. So this malloc function returns a void pointer. So this void pointer must be converted to, it must be converted to the void pointer must be converted to whatever data type you want. So that's why here typecasting must be done. So here typecasting must be converted to which one? So our struct node asterisk. So instead of writing struct node asterisk, you can give it as nptr. So you can give it as simply nptr, because we have given the alias name for struct node asterisk as nptr. So the typecasting, so the void pointer will be converted to what type? Struct node asterisk type, because here H is also is of that type. So now first of all we have done the typecasting, that is this one. The typecasting has been done. Next you have to give the function name, that is malloc. So you have to give the function name malloc. So now you have given the function name malloc. And next you have to give the size that is required for your node. The size that is required for your node. So how you can know the size of that one? You can use the size of operator. Size of operator in C language. You can use the size of operator, and you can give the data type name. So how you can find the data size of any data type? So just you can give the data type name within this operator size of. So here what is our data type? It is a user defined data type, that is struct node. The data type is struct s node. Okay, it is struct node. So struct node. So this is how you can allocate memory to your header file. So what is happening here? First of all, typecasting is being done. That is from void. So malloc function will return a void pointer. This void pointer is converted to your data type pointer. So here our data type pointer is struct node asterisk. So that's why it is converted to struct node. And then how much memory you have to allocate to your node? So it is, for example, in this case, it is, what is the size? It is for data it requires 2 bytes, and for link part it requires 2 bytes. So total how much memory? So it requires 4 bytes. Suppose if you give size of struct node means it will return 4 bytes for you. So it will allocate how many bytes? 4 bytes of memory for your header node. It will allocate 4 bytes of memory to your header node. So now the 4 bytes of memory is allocated, and the memory address is assigned to H. So if the memory is, so now what we have to do? So we have to check whether the memory is allocated or not. Without checking we should not proceed. So now in order to check, what you can do? If H is double equal to null. If H is double equal to null. What we are doing here? We are checking if H is double equal to null. Means what? Suppose if it is equal to null, it indicates that the memory has not been allocated to H. So if it returns null means, instead of giving the address of your memory location, if it returns null means it indicates that the memory is not allocated to your variable H. So then what we have to do? If the memory is not allocated, can we proceed in our problem? We can't proceed. So that's why what we have to do? We have to come out of our program. So what we will do? Just we will print a message, printf out of memory space, out of memory space. Just we will give a message to the user because he should understand why the program has been exited. Okay, so that's why for that one just we are giving some simple error message, that is out of memory space. The required amount of memory is not there in the system. We are giving a simple message, and then just we will give return. And if the memory is allocated, then we should return that pointer. But here the memory is not allocated. So that's why what I am returning? I am returning null. I am returning null. So null will be returned. So suppose if it comes to this condition, means what? The memory is not allocated for H. So that's why abnormal. So abnormal termination. Just it is returning out of our function. So just it will return null and it will come out of our function. Suppose if it doesn't come, if this condition is false, then it will come to this statement, isn't it? So that means it won't go here and it won't return with null. So if it comes to this statement means it indicates that the memory has been allocated to H. So once the memory is allocated to H, then what we have to do? So do we have any list till now? This is the header node. So we don't have any node, isn't it? So that's why what you have to do is you have to place null here. So that is H. How you can access the elements of your structure? Because this is a pointer. So structure variable. Whenever if you want to access the elements of a structure, the syntax is structure variable. Structure variable. Next you have to give member access operator. And then you have to give the structure member. So that means, suppose here we have the member access operators as dot and hyphen greater than. So this is used for normal variables and this is used for pointer variables. So now here what is our variable? Here H is of type, which type of variable? It is a pointer variable. So because it is the data type of struct here, NPTR means what? It is struct node asterisk. Here asterisk is there. That means it is a pointer. So pointer means here the variable structure variable is H and member access operator is hyphen greater than. And what is the structure member? The structure member is, it is, here we have two members. One is data and another one is next. So how you can access the data means you can give it as H hyphen greater than data, and similarly how you can access the next is hyphen greater than H hyphen greater than null. Another one how you can access is H hyphen greater than next. So this is how you can access the data members of your structure. So how we can access the next? H hyphen greater than is equal to, what you have to place in your header? You have to place null because the list is empty at present. So that's why what we will do? We will give null for the H next. So once the null is given, then what we have to do? So we have to, what we have to do is we have to, that means we have created a header node and placing the H next as null. So once the header node is created, what you have to do? You have to return this address to the calling place. So how you can return the address of H? Just you give it as return H. So now your header node is created. So now your header node is created here. So this is how you can create a header node in a singly linked list. So suppose if you want to work with the singly linked list, so first of all you have to create a header node which maintains the details, that is the total list. Okay, so if you like my video, please like, share and subscribe to our channel.